This is grade 12 University Physics, Unit 1 Dynamics, Lesson 12 Frictional Forces, and we're going to try the challenge question on the back of the handout. Here we have two masses connected by a massless string hanging over a pulley that connects two inclines. Mass 1 is 8 kilograms and mass 2 is 12 kilograms. The coefficient of kinetic friction for both inclines is 0.21. Determine the acceleration of the two masses. So let's start by drawing this out. Once we draw it out, here we have one box which is going to be pulled up the incline due to a force of tension. The other box, the heavier box, will be sliding down the incline, providing that tension to the first box due to the force of gravity or component thereof. Once we have it all drawn, we need to add our forces for both free body diagrams. On the first one, we have kinetic friction, normal force, tension, and gravity. On the second one, we have normal force, again, kinetic friction, tension, and gravity. Now we need to have a coordinate system, and you want to always choose your coordinate system to be aligned with the direction of acceleration. That way we don't have to worry about components for acceleration. Now our coordinate system is going to be rotated by the pulley, so it's going to be slightly rotated for our second free body diagram. Once we have this coordinate system, we need to draw the components for any forces which are not aligned with our coordinate system. And for both of our free body diagrams, it turns out we need to draw the components for gravity. So we'll do that, and we'll make sure to calculate both the x and y components for both. Now we can start by writing Newton's second law of motion. And what we're going to do is we're going to consider both masses as a system. So we're going to take the sum of all forces in our x component, since the question is asking for acceleration, and we're going to set that equal to the total mass times acceleration. Now if we look at the forces in our x component, we have kinetic friction for box 1, we have a component of gravity, and then we have a tension going up. But we also have a tension in the opposite direction for our second box. Now these tensions are equal and opposite, so their magnitudes are equal, their directions are opposite, so they're just going to cancel out, so we won't bother writing those in the equation. Now for the second box, we also have the force of kinetic friction and a component of gravity. Now, expanding our force for kinetic friction, it equals the coefficient times the normal force. And if you look at the y component for each free body diagram, we know that it must be in equilibrium since it's not accelerating in y. Therefore, the normal force would be equal to the y component of gravity. So we're just going to replace the normal forces with their respective y components of gravity. Once this is done, we can rearrange the equation a little bit, substitute in our values, our numbers, and we can get a value for acceleration of the two boxes to be 0.28 meters per second squared.